Okay, so the big rule, there's really two kind of rules for antiderivatives. One of them is the power rule, right? The power rule we talked about. The other one is it's not the chain rule, but it's kind of a chain rule. We'll learn about that next week. But for right now, the big one is the power rule, right? So to find an antiderivative, you add 1 to the power, right? Add 1 to the power, and then whatever that power is now, that's what you divide it by, right? That's what the power rule for antiderivatives is. And then we have a plus c. Why do we have a plus c there? Can you remind me why? Why do all of these guys, why do all of our antiderivative answers have a plus c? Hmm? Exactly, right? Because if they could have been a constant, they could have been a number, a regular number without a variable, right? And if we were to find the derivative of that, that would just be 0. That would have gone away, right? So we always have to put a plus c out there for that. Okay. Okay, so we stopped at number 3. So number 4, we talked about it, right? If this was a derivative question from last semester, I would use the chain rule, right? Move the 2 to the front, change the 1, change the 2 to a 1, then find the derivative of the inside chain rule, right? Well, we don't have a chain rule for antiderivatives. We kind of do, but we haven't learned that yet. So is there another way? We talked about that, right? What's the other way we can do number 4 without having to do any other rules besides power rule? What can we do to number 4 before we even find antiderivatives? Hmm? Multiply it out, yeah. Okay. So what I'm going to do real quick is I'm going to multiply, because 3x minus 1 squared just means 3x minus 1 times itself, right? So I'm going to FOIL real quick, distribute first 9x squared, inner negative 3x, outer negative 3x, last positive 1. And then remember, dx is always the tag that goes when we're doing antiderivatives. Dx always goes at the end. Don't worry about what it means right yet. I'll teach you that probably next week, but just for right now. Okay, and then we can combine the middle two. You see that the middle two can be combined to minus 6x. Okay. Now we can use the power rule for each term, right? The power rule. Add 1 to the power, divide by the new power. Okay, so 9x squared. 9x squared, I'm going to add a power. I'm going to add a power, so it's 9x to the third. Divide by 3. Okay. The next one, 6x, negative 6x. Add a power, so it's got a power of 1 right now, so now it's going to have a power of 2. Divide by that new power. Okay. And then the 1. The 1 doesn't have an x, so it's just going to be 1x to the first power divided by 1, right? But that's just x. So you really don't even need that. Okay, it doesn't hurt, but you don't need it. We're done, but then we can finish with a plus c, right? A plus c. Okay. Only other thing to do is kind of divide. Some of them can be divided. The first 2 terms can be divided, right? So 3 goes into 9 3 times. So 3x cubed minus 3x squared plus x plus c. Done. Okay, not too bad. The last one, number 5 on that page. The last one on that page. How do you think I'm going to do this, right? When you first look at it, you think quotient rule, right? There's a quotient. When we found derivatives, like if this was a derivative question, we would use quotient rule. But we don't have a quotient rule. There is no quotient rule for antiderivatives, right? I told you there's a chain rule, kind of a chain rule thing, but I haven't taught you that. But there is no product or quotient rule. They don't exist for antiderivatives. Less rules, but how do I use this? What do you think I'm going to do to find the antiderivative of this using power rule? Yeah, Rob. Yeah. The 1/2 x on the bottom. First, definitely change that. Definitely change that. So let's change the problem. I'm not doing anything. I'm just changing the way the problem looks. So instead of a, and then Roman, you said change it to a negative. So if I change it to a negative, it can move up, right? If I change it to a negative, it can move up. Okay. So be careful when you do that, because what is that going to look like when I move it up? We can do that, but we have to do it correctly algebraically. So when the 1/2 moves up, sorry, what do we do? There you go. It's going to be a multiplication problem. Yeah. So when the 1/2 moves up, it's going to be x to the 1/2, and then x plus 1 is going to stay there. Oops, sorry, it's a negative. No, it's a negative. Distribute. Distribute. So when I distribute x to the negative 1/2 times x, what do I get? How do I figure that out? X to the negative 1/2 times x. What do I get? So this is a 1, right? We're multiplying x to the negative 1/2 times x. So what do I do with the powers? Add them. There you go, add them. So it's actually going to be 1/2, positive 1/2. Okay. And then I distribute to the positive 1. Well, anything times 1 is just itself. So it's just going to stay x to the negative 1/2. Okay. Now I can do the problem. Now I can actually use the power rule. I have powers. I don't have any roots. I don't have any fraction, or I don't have any division or anything, so I can do the power rule now. Okay. So when I do that, first x to the 1/2, add 1 to the power. So instead of subtracting 1 like you're used to with derivatives, we're adding 1 to the power. So if I add a whole, it's going to be 3/2. Divide by that new power. So when I divide by the new power, what am I really doing? When you're dividing by a fraction, right? Because I don't want to divide by a fraction because that looks ugly. When I divide by a fraction, what am I really doing? There you go, multiplying by the reciprocal. So instead of dividing by 3/2, let's just say times 2/3. It's a lot cleaner that way. Okay, that's the first one. The next term right here, same thing, but a negative now, a negative 1/2. We'll add 1 whole. So when I add 1 whole, I get positive 1/2. Again, instead of dividing by 1/2, let's multiply by the reciprocal. What's the reciprocal of 1/2? 2, 2 whole. Don't need the 1 anymore. Plus c. Done. I mean, you can change it around. I mean, there's no negative exponents, so there's really nothing to change. There's nothing that cancels out. That's a good answer right there. Okay. All right. Okay, so last thing, because it's not hard. Let's look at these guys here. Look at the next one down, the trig integrals. Those look familiar. Don't look at the integration sign, the S. Don't look at that. Look at everything else. So look at these things here. Oops, not the dx. Those look familiar in yellow? All of them collectively, do they look familiar? They should. Where do they come from? The first two, sine and cosine, obviously. But why did I choose secant squared instead of regular secant? Why did I choose cosecant squared instead of regular cosecant? Why did I put secant and tangent together here? Why did I put cosecant and cotangent together here? They're the derivatives, right? Those are on our sheets. So now what we got to do is go the other way. Other way. So what's the antiderivative of sine? What's the antiderivative of sine? Negative cosine. Yeah, negative cosine. Plus c. Right? What's the antiderivative of cosine? Buried somewhere in your notes. Well, you should have this paper here. This sheet, right, with the unit circle in the front. That one has the answers too. But somewhere buried from last semester, you should have the wheel, right? Uh, right? The wheel of sine and cosine. If we go to the right, it's derivatives. So if we want antiderivatives, we just go to the left, right? Let me put this on the notes too. So for sine and cosine, right? Because the derivative of sine is cosine. The derivative of cosine is negative sine. And then the derivative of negative sine is negative cosine. And then the derivative of negative cosine is regular sine and goes back and forth. So we're just going the opposite direction. So the first one was sine. So we went backwards, negative cosine. So number two, what's the antiderivative of cosine? Sine, regular sine. Okay. Secant squared. Where does secant squared come from? Secant squared sounds familiar. Where did it come from? Tangent, right? It was the derivative of tangent. So if the derivative of tangent is secant squared, what's the antiderivative of secant squared? Tangent. On your last semester, we were going one way. Now we're going the other way. Cosecant squared. Where does cosecant squared come from? Where does cosecant squared? What was the derivative that gave you, when I took the derivative of what, it gave me cosecant squared? I'll give you a hint. We've used cosine, tangent, and sine, cosine, and tangent. What are left? Cosecant squared. It's cotangent, but there's a little caveat there, right? If I found the derivative of cotangent is negative cosecant squared. So how do I answer this question? There you go. Yep. Mm-hmm. Okay, secant squared tangent. Secant tangent. Secant x tangent x. Where did that come from? Yep, that was the derivative of secant. So the antiderivative of that is secant. Last one, cosecant, cotangent. Cosecant, cotangent. Which one is that going to be? Cosecant, yeah. But again, this one has a little caveat though, because the derivative of cosecant was negative cosecant cotangent. Okay, so we just got to include a negative like we did for number 1 and number 4. Okay. Okay. So they won't ask you things that aren't on the list. Like they won't say this. They won't say, what is that? Right? And you go to your list and you're like, oh, it's not on my list. They won't ask you those things. Okay. So you don't have to worry about things that aren't on my list. Right? Just focus on these. So really, you're not having to memorize anything because you already knew this from last semester. It's just we're going the other direction. That's it. Okay. That is it. So tomorrow, what we're going to do is we're going to focus on those 2 things we're going to do tomorrow. We're going to focus on, we're going to do these problems here. And then we got a couple more that are not different. They ask you to do something a little different. Okay. And then, so let's do number 1 together. Since number 1 won't take it that long. Number 1 won't take it that long. We got 6 minutes. So it's 4 times sine x. So how do I find the antiderivative of that? A couple things you can do. You can move 4 to the front to get rid of it. And then this part here, oops, not that part, this part. I just look up from the ones I just did. It's right here. So multiply that times what I already had in front. And you get negative 4 cosine x plus c. Okay. All right. Okay, so tomorrow what we're going to do is we're going to finish this. Your assignment's not going to come from Delta Math on this one. Your assignment's going to come from the book. You don't have to bring your book tomorrow. I'll post the page on Google Classroom. But I just want to let you know that your assignment from this, which I'll assign tomorrow, okay. The only thing that's out there right now that's still due is the lesson from Monday, L'Hôpital's. Okay. Everything else, like I said, I haven't assigned a new. We'll do that tomorrow. Okay. So we'll pick up where we left off tomorrow. All right.